All right, so holes. So holes are places in the function, where there is a hole. Pretty much all there is to it. Okay, what that means is instead of a nice continuous line that you guys draw, there's going to be a point on the function where literally the function doesn't exist, meaning that there's literally going to be like a round circular hole there. Where these happen in your rational functions are these happen places where factors cross out or simplified, and we'll find out what that means soon in a second. So we can find out where the holes are in your rational functions, where if we're able to cross out or simplify things from the numerator and the denominator, and the holes are going to happen at the factors where we cross it out. So over here we have a couple of functions where they're going to be holes. These guys will have holes. Not every function has them. So yeah, we'll see how these guys are, how these holes are going to work. So first I'm going to make this smaller so it's some room. Alright, so our first function is f of x equals f of x minus 3. Let's write that over here. Okay, x equals 2 x minus 3 over x minus 3. Alright, so if you notice, these guys at the top and bottom are the same. So we can simplify this fraction to be, we'll use another color to cross these out. F of x equals to 1. What is this? Oops. Alright, so f of x equals to 1. Okay, so what this means is our function, our original function, f of x equals x minus 3, is going to look exactly the same as this guy, as f of x equals to 1. However, the only difference is there's going to be a hole at x equals to 3, because the factor we crossed out was x minus 3. If you remember from your polynomial unit, the number corresponding to x minus 3 is 3. So it's going to look exactly like this guy, but what's going to happen is at 3, there's going to be a hole right at the right where it is. So usually we'll write therefore hole at x equals to 3. And to figure out what that point is, all we have to do is to substitute where the hole is, x equals to 3, into the simplified version of the function, and that'll get us the coordinates of the hole. So let's do that. F of 3 equals to 1. Therefore, we have a hole at 3 and 1. Okay, so we'll plot these guys in a second. So let's do that right now, just to show all of this stuff on Desmos. Okay, so let's graph it. Our function we have was x minus 3 over x minus 3. Okay, equals. So it looks like a line, which doesn't really look like a usual rational function, but we simplified this, remember? So if you compare the graphs of our original and our simplified, they are exactly the same graph. And then we'll get to the point where there's a hole at 3 and 1 up over here. So if you look on our actual function, if we kind of use Desmos, so at 3, you can see that it is undefined. Because if we substitute 3 into our function over here, you imagine substituting 3 in here, we're going to get 3 minus 3, which is 0, over 3 minus 3, which is also 0. So 0 over 0 is technically undefined. In calculus and other areas. 0 over 0 is indeterminate, which is a little bit different than what undefined means, but for all intents and purposes, for this case, 0 over 0 will be undefined on our function. So yeah, here we go. So let's do another example. Okay, so the next example we have is this one. So let's write this out. F of x equals to x plus 2 whole over x squared minus 3x minus 10. So with these guys, there isn't anything that we can cross out immediately. Right, as you can see, there's nothing we can cross out, but we can factor the very bottom. And when we do this, you can see that we're going to get something that we're going to be able to cross out. Bottom becomes x minus 5, x plus 2. This is just quadratic factoring. Okay, so you can see over here we have factors that we can cross out, the x plus 2 and the x plus 2 down here. So if we simplify this, we will get f of x equals 1 over x minus 5. Okay, so just like before, what this means is our original function, f of x equals x plus 2 over x squared minus 3x minus 10, is going to look exactly the same as this guy, as our simplified version. The only difference is there's going to be a hole at the factor that we crossed out or simplified. So since we crossed out x plus 2, we're going to have a hole at x minus 2. So hole at, well, negative 2. X equals negative 2. Nice. And then we can find out the coordinates of our hole, the other y coordinate, by substituting the x coordinate into the simplified version. And that will actually help us find where the hole is. So this is f of negative 2 equals to 1 over negative 2 minus 5, which is negative 1 over 7. So our hole is going to be at negative 2, negative 1 over 7. Okay, so let's go to Desmos once again and take a look at the graphs to get like a good visual representation of this. Let's graph both of them. The original version we had was x plus 2, x squared minus 3x minus 10. And the other version we have is 1 over x minus 5 or simplified. So you can already see that both graphs are the exact same graph. However, we're going to take a look at what happens at negative 2, because we said that there's a hole at negative 2. So on our red function original, look at negative 2. It is undefined. There we go. Once again, there's a hole at the factor that we crossed out right there. And the y coordinate is negative 1 over 7, which corresponds to the 1 in our simplified version. So at negative 2, you can put this into your calculator. 1 divided by 7 is negative 0.143, and that's the location of the hole originally. There we go. So yeah, that's it. Those are what holes are. So just to reiterate what holes are, these are places in the function where there is a hole instead of a point. So I guess instead of a point. Okay, let's make this longer. Okay, these happen where factors are crossed out or simplified. And I guess the last point is we can determine coordinates of the hole by subbing in x coordinate into the simplified function. There you have it. That is what a hole is.